In this video, we're going to be looking at the graphs of inverses. And let's see what those graphs look like when you do have two relations that are inverses. The first example says, given triangle ABC is formed by the points in the relation -1, 6, -7, 2, and 5, -3. And let's go ahead and graph those points. So there's the graph of my triangle. It says, what is the inverse of this relation? And again, to find the inverse of a relation, you simply take your x and y's and you flip-flop them. So there would be the inverse of your relation. And then it says graph ABC, which you've already done, and its inverse. What do you notice about the graphs? So let's go ahead and graph the inverse. And there you see a picture of your inverse function. Now, what do we notice, or inverse relation, excuse me. What do we notice about these two graphs? These two graphs are perfect mirror images. Notice the line y equals x that I've drawn. These two graphs are perfectly reflected across the line y equals x. And you can go back and reminder from geometry, if you go back and study your transformations to reflect something across the line y equals x, if you don't remember, xy turns into yx. Wait a minute, isn't that how you find an inverse? Don't you switch your x's and y's? Yes. So therefore, if we switch our x and y's, if we do it correctly, we should have mirror images across the line y equals x. So now, let's go down and work some more examples. Number 1 says find the inverse of each function, then graph both functions and verify the inverse relationship on the graph. So we don't have to do f of g and g of f anymore. We're going to verify it with a graph by seeing, are they mirror images of each other? So now let's first find our inverse, y equals 2x plus 8. The inverse of that would be x equals 2y plus 8. Simply switch your x and y's. Solve for y, move the 8 over. X minus 8 is equal to 2y, and then divide by 2, and that gives you your inverse. F inverse then should be, and you could actually split this and do 1 divided by 2, x, minus 8 divided by 2, which would be 4. So these two functions should be inverses. They're linear, so we can actually just use y equals mx plus b to graph them. Let me zoom in, and let's get those two functions on your graph. Okay, here you see a picture of both functions. Y equals 2x plus 8 is the green, y equals 1/2 x minus 4. And again, notice the mirror images. You have the point here, -4 is 0, and the point here is 0, -4. And you can actually do that with every point on the graph. And it should both be perfect XY swaps for every single point. Number 2, your original graph is y equals 1/3 x minus 1. The inverse of that would be x equals 1/3 y minus 1. Let's now solve that for y. Move the 1 over by adding 1, so you have x equals, or x plus 1 equals 1/3 y. To get rid of 1/3, you're going to multiply the other side by its reciprocal, so multiply everything by 3, and you get f inverse is 3x plus 3. Let's graph that in green. We'll graph the other one in pink, and let's see if we have true inverses. Okay, so here again you see that I've graphed the line y equals x along with the pink and green graphs, and they are again mirror images, and you can check any point. Here's 0, 3, and here's 3, 0. Every point is going to be x, y switches. The next one, let's go ahead and graph y equals x squared minus 4. Just to remind you, we're only going to plug in values to the right of 0. So we're not going to graph anywhere over here. We're only going to graph the right side of that graph. When you plug in 0, you get -4. When you plug in 1, you get -3. When you plug in 2, you get 0. When you plug in 3, you get 5. 1, 2, 3, 4, 5. So this graph is going to look like this. Now let's go ahead and find the inverse of that and see if we can graph it as well. So we have y equals x squared minus 4 is the original, so x equals y squared minus 4 is going to be the inverse. Let's get y by itself, move the 4 over, be x plus 4 is equal to y squared. So to get rid of the squared, we're going to do plus and minus the square root. However, if you'll go back to the original, this is very important. The domain is x is greater than or equal to 0. If you plug that in, the range would be values greater than -4. So therefore, when you find the inverse, which is f inverse is, I've got a plus and minus here now, but we're probably going to have to get rid of that because here's what we want. We want our new domain to be values, x values, are going to be greater than or equal to -4, and our new range will be y values are greater than or equal to 1. Again, we simply switch our domain and range from up here since we have that restriction. If we want our y values to be positive, that's what this says. When I plug things into this, if I do plus and minus, that gives me positive and negative y values. I only want the positive ones. So let's take away that plus or minus, and let's only deal with positive y values. Now let's plug some x values in here. Make sure that your x values that you're plugging in are only the ones greater than or equal to -4. And let's see what our graph looks like. And there you see my new graph is a mirror image. I went ahead and graphed y equals x along with it, and they are perfect mirror images of each other across that line y equals x.